All right, we need the data or MyOpenMath, and we're going to do the descriptive statistics Excel. So we need to be in that, download that one, and it should look like that. In this, we've got data, but also what we need is the data analysis ToolPak. And this is already in Excel. And if you go to the Data tab at the very top, if you have the Data Analysis ToolPak, it will show up on the far right. It will be up in here. This is already in Excel, and it is already ready to go. It just isn't on the menu. For these, you can load this on your own computer. If you put it up on this, it gets flicked off at midnight. You'd have to reload it. If you go to File and More, down at the very bottom, there's an Options place on the menu. What we want is the add-ins. And these are the things that Excel can do and will bring up. What we want is the Analysis ToolPak. But to load the Analysis ToolPak, right now it says it's inactive. We want to go down to Excel add-ins at the very bottom, and we want to go on that. And these are the things that are already in there. They're just not on the menu. This is just puts them on the menu. You don't have to go anywhere. You don't have to get online, download anything. We want the Analysis ToolPak. Click OK. So we should have that loaded. I go back, and now if you go to the Data tab, there is Data Analysis. This tab has a whole bunch of statistics function that aren't on the main menus. What we want right now is descriptive statistics. And if you click on descriptive statistics, you get this generic box. It's got an input box and an output range box. I'm going to do the input range and mark the information that's there. It doesn't matter how much or how little, but it only does one variable statistics, one column. So we need output range. And if you scroll down a little ways, click in there, there's a place to put this. This is so they all match up. It isn't necessary, but this is just the easy way to do it. And then we want summary statistics. This is the summary statistics for that particular list of numbers. This is the mean, and if we went and calculated the mean, average of that list of numbers, there's the average. If we did the median, we would get the median. The mode, if it exists, is on there. All of these things match this list of things here that you can do. So all of these have their counterparts in the regular commands. And this just gets you the basic statistics on a list of numbers. This is the assignment in here, is to do this and also do this. So we're going to go down this list because there's things on here we haven't done and things we have. Find the median. And the median is 14.9, comes in here and there. The mode is 14.9, and this is a fake mode because we've only got 16 numbers, and in here there's a forced pair. It occurs twice rather than just a bunch of numbers. So it's kind of a fake mode. This is the sample standard deviation, the stdev.s. There's the numbers. So the standard deviation here matches the standard deviation there, stdev.s. The population standard deviation uses the stdev.p command. And this is if we assumed that we knew the population mean, which you're never going to do, but this is an engineer's version of statistics. And this is slightly smaller than the sample standard deviation, stdev.s, because the divisor for this one is n-1. We've given away 1 degree of freedom, estimating the mean. This one, that's the difference. We say we know the mean, we don't give up a degree of freedom. Right? If the sample size is like 30, there's no practical difference in these numbers. Because the difference between the square root of n-1 and n is very small when you get to bigger numbers. This is the sample variance. This is the square of the standard deviation. So that if I square standard deviation, I get the sample variance. See how to, I got way too many decimals here. The sample variance is important in other applications of statistics. It is almost meaningless to us. We had to have the variance because that's what we had to calculate with an old calculator or by hand. You had to go through, get the difference, square it, add it up, then take the square root, which was an adventure in itself. So that the sample variance used to be the way we got to the standard deviation. It is no longer. Now we type in stdev.s and you've got a number. So this is an artifact of old calculation as far as we're concerned. The population variance is the square of the population standard deviation, stdev.p. Okay, so you didn't like it. This difference between the divisors is much more apparent The difference between the population variance and the sample variance is the divisor of the sample size. The minimum is just the minimum. It's got minimum and maximum in the summary statistics list. One thing it doesn't have is the quartiles. You can use the EXC or the INC, and there's an explanation of the difference between these two things on one of the screens, but it doesn't matter if you've got enough numbers. We'll use EXC. Why not? And if you did the INC with this sample size, you would get a difference. We want the first quartile, 5.125. The second quartile is the same thing with a 2 at the end. Here's the data, comma 2. That's the second quartile. The third quartile is the same thing. Array oh yeah, I know. Comma 3. I need the 3 in there. And the maximum, same deal. So these are the things you would use to make the box plot. This is the 5-number summary, maximum, third, second, first, and minimum. This is a percentile. And this one isn't in this. We need the percentile command. This will give us any percentile that we want. The first quartile is the 25th percentile. The median is the 50th percentile. The third quartile is the 75th percentile. We want, in this one, the 90th percentile. We can use anything, but the command is equals. And then, what do you suppose percentile command would be? Percentile, or at least start, PER. And again, we've got the same percentile exclusive and inclusive. And again, if you've got enough numbers, it doesn't matter. We'll just use the EXC. Mark the array. Comma, and then we need to tell it what the percentile is. And in this, if you enter 90, you'll get an error. It wants a decimal. If you do it 90 first, you get an error, go back and change it to 0.9. So we need 0.9 for the 90th percentile. If we put in 0.25, we would have gotten the first quartile. So this says that in this list of numbers, 90% are less than 38.35. this is a percentile backwards. What is the value of the percentile for a phone call that lasts 11.5 minutes? So it's the opposite of the percentile command. PER. And this one, we need the percent rank. Instead of percentile, we want percent rank. We're going the other way, and it's got the inclusive and exclusive. Percent rank is fine, EXC. Then we put in the array, mark the numbers. All these commands are basically the same layout, always. Comma. Then it wants the X value. And put in 11.5, and it will find the rank of 11.5 in that list of numbers. Also here, it has significance, which is how many decimals you want. Anything that is in square brackets in Excel is optional. You don't have to put it in there. We may as well use it, comma, 3. Close it, so that the percentile for 11.5 minutes is 0.411, the 41st percentile. And another percent rank. This one says, why is the sample standard deviation than the population standard deviation? What's the difference? It's the divisor, n versus n minus 1. Now, we can draw a box plot. Go back up to the data, and we'll just use the unsorted data. Mark the data. We're going to make a graph by going with the data first and then to the graph. You can do the graph, then select data. Either way, this one we're going to do the easy way. We've got a data set. Go to Insert, and up here is Recommended Charts. There are the standard ones, bar charts, line graphs, pie charts, XY graphs, and so forth. But you need to go to Recommended Charts and then All Charts. And if you look down the list, this is all of the charts. But down at the bottom, or toward the bottom, is the box and whiskers plot. And if you click on box and whiskers plot, it will show you what it's going to do. These are always presented vertically rather than horizontally. It's just a matter of which way you want your box plots to go. Say OK on the box and whiskers plot, and there it is. We have a chart title. We can keep or delete, change. But now, if you look on your chart, there's an X here. This is the average. This line, although it coincides with almost with the 15 here, is the median. So this is the minimum, first, second, third quartile, and the maximum. So for this distribution, it is skewed right. You have to imagine skewed up, or take this thing and turn it on its side. You can actually copy this and make it into an object and then turn it on its side. There's ways to do it. But then if you right-click inside, you will get the format data series command and add data labels. First, let's add data labels. And it shows the values of the quartiles, the minimum, the maximum, and the average. And that's pretty much all you can get on there. I don't know what else it might do. Format data labels. You can put some other stuff on there, and you can move them around. You want them on the right, the left, the middle, whatever. To get rid of the data labels, you have to delete them. Just mark one and then press delete. More important is format data series. Right-click, format data series, and in this, we can show inner points. This shows all of the data. This show outlier points is the default, and an outlier in these things is anything that is more than one interquartile range greater than the maximum, or whatever's on the graph is the maximum, or less than the minimum. And this to me is, there's entertainment value in it, but it's not particularly useful. But if you see dots outside or below the minimum or maximum, the ends, this is when people will use a 10%. Rather than the minimum, they use the 10th percentile and the 90th percentile, and then anything outside of that is marked as an outlier. So it depends on who's doing the box plot. They aren't standard because of the definitions that people use. Show the mean. You can turn the mean off or turn it on. You can show it as a line. And it's in there. It's just hard to see. But look here at gap width. If you change the gap width, you can change it with the slider or with the percent, and this, oddly enough, changes the width of the bar chart or of the box plot. So you can make it narrower or longer. You can change the up-down by changing the X or the Y axis. We want to make it smaller. We can make this to 100, and that'll squeeze it down. The gap width changes this. The regular axis command changes the up-down. So you can make it look like what you want. You can change from using the EXC command to the INC command by choosing one of those buttons. And it will change. You can see the change for this amount of data. This would be the INC, quartile.inc and quartile.exc. The box plot is built into Excel. You don't have to draw the box plot. You can plot it. Data Analysis ToolPak. On the Data tab, Data Analysis, and these are pretty sophisticated statistical analyses. But one that is useful is the histogram. And this is another version of the frequency command. Right, for the moment, we need data. This isn't enough data to really get a good distribution. So click on the bottom. We're going to add a sheet. And here I'm just going to put 1, 2, and you can add up successive numbers, or if you've got the fill command, home, fill, series, all I'm doing is making this so I know how many numbers I've got. I'm going to have a sample size of 40. So if you use the fill command or start with 1, the next cell is that one plus 1, copy that down. Either way works. Or you can type in 1 through 40. This next one, we're going to get a random number between 10 and 50. You remember the command for random number. What's rand start with? Yeah. Equals RAND. And we want rand between. Here's the radians command. If you're doing any kind of trigonometry, you can do it in radians or degrees. But we want rand between. And we want 10 to 50. And this also is just Excel practice. You're doing one more thing. If you go to the box and you go to that little square on the bottom right, get the X, you can push the mouse button down and pull down that command to copy. Or a shortcut, go to that box, get on the corner, get your X, and click. Double click. And it copies down to match the length of the column to the left of it. It's just a convenient way to do this. Now, everybody's got different numbers. And if you do Shift 9, this will change. We don't want it to change quite so drastically. So I'm going to copy these numbers over. Copy. Pick a spot. And then paste values. This one will change every time I change something in the spreadsheet. This will stay the same if I paste values. Here, I'm going to put in 10, 20, 30, 40, 50. These are going to be my bins, and I can do the frequency command. Frequency. First thing, mark the data array, comma, then the bins array, and I get the frequency distribution, and I can make a histogram out of that. That's frequency. You get it? Did it work? Yeah.
Can you repeat that one more time?
Yeah.
Sorry.
No problem. I picked a spot. Basically, you don't have to be here. You can be elsewhere and still do frequency. This just puts it next to the bins. Mark the empty spaces. Then, without doing anything else, type equals and FRE. And we get frequency. I'll double click in there. then it wants the data array, which is my numbers here, random numbers. Then comma, and it says, now I want the bins array. This is how it's going to put them into categories, and mark that, close it, and press enter. Did it work? Okay, that's the frequency command. Now go to Data and the Data Analysis ToolPak. And here we want the histogram command. You click on histogram or say OK. It gives you the usual dialog box, except now we put in the input range. And that's the data that we want to have a histogram for, or get frequency for. The bin range is the same bins as before, but now we can control where the output goes. If you click in this box, we get an output range, and pick a spot. And it's going to make a frequency distribution. Other things you can do in here is do a Pareto chart. And a Pareto chart is a particular bar chart or frequency distribution which makes the highest category appear on the left. A Pareto chart is a way to look at what's most important. Suppose I have accident statistics, and each one of these bins is like drunk driving, driving without a license, driving on ice, and so forth. And the Pareto chart will make this box plot, or the frequency distribution, histogram, highest to lowest. So that if you're trying to fix something, this will help you identify the most important. So that's the function of a Pareto chart. And it will show high, next, next, next in the histogram. Cumulative percentage is just a cumulative, it's an ogive. We're good. We want that data, that bin range, and I want to put it there. And if you click OK, it puts the bins and the frequency, which is exactly the same as this one, in that spot. You just have more control with the frequency or with the histogram than you do with the frequency. Right? That's the numerical summary assignment in Excel and the histogram command and the box plot command. Any questions on those? Yes?
What do you want us to submit for the descriptive statistics, like photo?
Pardon?
Because there's an assignment that's due, I think, today.
Yeah.
It's like taking photos of our work and sending it in. What do you want us to take a picture of this?
Oh, no. That's just an alternative to submitting it in Canvas.
Okay.
All right. Sometimes Canvas doesn't like whatever you're trying to give it. And if you need to do the screenshot, submit that. But that's all that is. Yeah, you don't have to take a picture of something. It's just a way around a problem that Canvas has sometimes. And I need to check the wording and make sure it doesn't say something stupid, which I do all the time. I'm over it.
How would we submit it in then? Just on my open math? Is that
No, you have to go to Canvas. Go to the Canvas page, Assignments, and there's a place to click on and submit a file, the Excel file. Which, if I could get on Canvas reliably, I would show you. All right? That's it. I'm going to do the Canvas thing so you can see where the assignment is if you want to wait on that. Otherwise, if you can find it for yourself, go away.
Question.
Yes, ma'am.
I was a little behind. Where you have bins and frequency, that whole thing. Can you show me how to generate that again?
Oh, yeah. Go to Data Analysis and Histogram. Make sure it's marked. You can double click on that or just say OK. And Excel remembers what you had in here, so if you've got a different setup, you've got to erase all of this. So I'm going to erase this stuff. The bin range and the output range, and start again. And the input is the list of numbers that we have. Just mark it like you would for the frequency command. Click. You got it? Then the bin range is the bins that I want, the 10, 20, 30, 40, 50. And the output range is where I want to put the result. The frequency command is more limited in this, so that this one, I can put the result in a particular spot, and I click OK. And that's it.
It's not letting me click on the output range.
You have to click on the little box to the side. What's this? Okay.
There's a problem with this formula.
To the OK. Let's see. Go back to, click on New Sheet. We just want it to go somewhere else. It doesn't like anything about that. It's got something it doesn't like in the bins. Now try the output range.
And that's just wherever.
You just wherever. Yeah, it didn't like what something was wrong with the.
Alright, cool. Thank you.
Okay, I ended up finding it, so thank you.
Okay, good.
I didn't realize that you could upload files and you didn't have to take the photo, so half
Oh.
of mine are in photos, so I apologize.
Yeah, that's all right. I entered my username.
Thank you.
Yeah. No problem. Canvas, assignments, and there's each of the assignments. So descriptive statistics, you have to choose a file. Oh, I need to view a student. There it is. Submit the file, upload. Click in here, choose a file, it uploads it, and there it is.
So are the assignments like what we've been doing in class?
The assignments are the Excel things, and we're going to do them in class.
Okay. Gotcha. Yeah, I figured. I wasn't sure if it was just like another assignment that I didn't see or something.
No, it's an Excel assignment, and it doesn't fit in the MyOpenMath format.
Okay. And then is it actually due today, or is this
No, next Friday. Yep. All that stuff was moved back a week.
Cool. Just want to double check on it.
Mm-hmm.
Thank you. Have a good week.
Okay.